Hello students, so I just wanted to show you this Calorimetry Lab. This is the way that we can figure out how much energy in terms of calories is in a variety of foods. To get to this lab, you'll start by going to these virtual biology labs and click on the first one, Calorimetry. How much energy is in the food you eat?
Do you know how many calories are in the foods you eat? You've probably heard dieters say that they're counting calories or that they need to burn calories to lose weight. On all packaged foods, the nutrition label tells you how many calories are in each serving. But how are calories determined? In this investigation, you will select foods from different food groups and determine the number of calories in each food sample.
All right, so now we know what we're going to be doing in this. Let's figure it out.
Explore the lab to learn what is available for your investigation. You must click on each item in the checklist. Once you are ready to move on, click Procedure.
All right, looks like the first thing in our checklist is the calorimeter. So here's that.
Calorimeter. Use the calorimeter to measure the energy stored in food by burning food samples. Burning food releases energy in the form of heat and light. Measuring the amount of heat given off by a sample of burning food can provide you with data to calculate the number of calories in the food sample.
All right, next one looks like thermometer. Here's the thermometer.
Thermometer. Use the thermometer to observe the change in water temperature before and after burning the food in the calorimeter. The change in water temperature is related to the amount of heat given off by the food sample.
Awesome. Looks like the next one is the balance. Here's our balance.
Balance. Use the balance to measure the mass of the food samples.
Awesome. Looks like next one is a crucible.
Crucible. A crucible is a small container that does not melt easily. Use the crucible to hold the food samples while in the calorimeter.
And then finally, here's our food samples.
Food samples. Carrots, broccoli, banana, orange, American cheese, chicken, tortilla, bread, chocolate, margarine blend.
All right, I think we are ready for the procedure.
Select 5 food samples to compare in your experiment and drag them to the workbench. Open the lab notebook to rank the foods in order from the fewest to the greatest number of calories per gram. Once you have recorded your predictions, click the arrow to advance to step 2.
All right, so I can choose any 5 that I want. I want to choose this margarine blend. That just looks like butter to me. Maybe a tortilla. Those are delicious. I think I'll try some broccoli. Let's see, maybe a banana. That's a good one. And obviously chocolate, because that seems delicious. So here's my lab notebook. I need to put them in the order I think they're going to be from fewest to greatest number of calories. I feel like I always hear broccoli is good for you. So I'll put it here. I can spell it correctly. We've got, I don't know, bananas maybe. Then what? Let's see. Maybe tortilla. I don't know, maybe chocolate next. It's just my guesses. And then maybe butter. Oh, it's margarine blend. Okay. Let's close that for now and go next.
Drag your first food sample to the crucible. Drag the crucible with the food sample to the balance to measure the initial mass of the crucible and the food sample to the nearest hundredth of a gram. Open the lab notebook and record the initial mass. Once you have recorded the initial mass, click the arrow to advance to step 3.
Okay, let's start with broccoli. It's closest. Let's take some broccoli sample, put it in my crucible. Let's get our initial mass. Looks like 16.07. Let's go to our lab notebook and say, okay, I'm starting with the broccoli, and what was it, 16.07?
Drag the crucible with a food sample to the calorimeter. Open the lab notebook and record the initial water temperature. Once you have recorded the initial water temperature, click the arrow to advance to step 4.
All right, get my crucible up in there, add some water. In this lab, we're adding 600 milliliters of water. Looks like our initial temperature is 20 degrees Celsius. So here's my lab notebook. My initial temperature looks like 20 degrees Celsius.
Click Ignite to burn the food sample. After the food is completely burned and reduced to ash, open the lab notebook and record the final water temperature. Once you have recorded the final water temperature, click the arrow to advance to step 5.
Okay, this should be fun. Ignite. Burn. Okay, seems like it's done. Turn to ash. Our final temperature is 20.6 degrees Celsius. Here we go, 20.6.
Drag the crucible from the calorimeter to the balance to measure the mass of the crucible and the burned food, ash. Open the lab notebook and record the final mass. Once you have recorded the final mass, click the arrow to advance to step 6.
All right, this part seems important because if I imagine burning some broccoli, I might not be able to burn all of it. So I want to know how much of it I actually burned. Looks like my final mass is 15.01 grams.
Drag your second food sample to the crucible, and drag the crucible with a food sample to the balance to measure the initial mass of the crucible and the food sample. Open the lab notebook and record the initial mass. Drag the crucible with a food sample to the calorimeter. Open the lab notebook and record the initial water temperature. Once you have recorded the initial mass and initial water temperature, click the arrow to advance to step 7.
So it seems like I'm just going to repeat the same process for each of the remaining foods.
Open the lab notebook and complete the calculations. Once you have completed the calculations, click the arrow to advance to step 15.
All right, calculations time. First of all, let's look at our data for just a moment. If you are not able to do this on your own, then this data might be a great thing to take a screenshot of, just so that you can see what all the data was showing us. We can see the initial mass and the final mass of each food after we burned them. We can also see the change in mass. Then we can see the initial and the final water temperature and the change in water temperature as well. Notice change in mass should really be negative because they're losing mass, and change in water temperature should really be positive because they're gaining water temperature. Okay, so let's go over to our calculate section. So it says to calculate the number of calories released by each food sample, enter the necessary value into the following formula, scroll down to get your change in water temp data from your experiment. Here we go. So it looks like our overall equation is this: 600 grams times the change in water temperature times 1 calorie per kilogram centigrade times 1 kilogram per 100 grams. So our first space here is change in water temperature. So if I scroll down here, It did that math for me. So for the tortilla, let's do that one, 5.20. 5.20. All right, and then it does some additional multiplication for me, and I end up with 3.12 calories. Let's write that down, 3.12. But I didn't burn the exact same amount of every food, so I want to divide it by my total grams so that I can figure out calories per gram. So now I just need to divide that. 3.12 divided by 1.08, 2.89. 2.89 calories per gram. Then I just need to repeat that process for each one of these foods. And here's my final data. If you're working from home and not able to do this on your own computer, you might want to take a screenshot of this. Notice if I look at the total amount of calories per gram in each one of these, I have chocolate as number one. Margarine is number one, chocolate is number two, tortilla is number three, banana is number four, and broccoli is number five. So now I just need to go to this final part, analyze and conclude.
You are now ready to analyze your data and draw your conclusions. Open the lab notebook and answer the questions.
All right, so it looks like my predictions were spot on. Guess I've done this before. Excellent. So it's going to have me say what might have accounted for any differences between your predictions. So I can say my predictions were spot on. Smiley face. Evaluate. How might multiple trials improve the accuracy of your results? Oh, that's a big one. There are a lot of potential sources of error in this lab. So additional trials might help to reduce the impact of that error on the final results. For example, I can imagine some of this heat being lost through the calorimeter. I could imagine not the same amount of every food being burned. I could imagine getting temperature at a slightly wrong time. And if I had multiple trials for each one, like say 5 trials or even 10, then I would have a large enough sample set to reduce some of that error. Apply. How can this information be used to help plan a healthful diet? Well, I know I need a certain amount of calories, and this tells me how we figure out how many calories there are. So this info tells me how we know what's on the nutrition label. These values are important for planning to eat the right amount and kind of food that your body needs. For example, number 4, evaluate. What are some other pieces of information about food this experiment did not provide? What else do you need to know to make healthful decisions about your diet? So this one only told me about calories, and I know amount of fat is important, amount of sugar is important. Everything else on that nutrition label, also important. It's only All right, finally, compare and contrast. What is the relationship between the release of energy in the form of heat and calories? So calories are a measure of energy, just like energy in the release of heat. The whole process of changing water temperature and doing all of those conversions basically just allows me to create this unit. Turns out that when I burn these things inside my body, that's literally what I do when I do cellular respiration, a similar process happens. Just instead of igniting and burning all at once, I sort of burn it, quote unquote, really slowly so that my body can use that energy for other things. With that, you are done. You can click done. You can also print this thing to turn it in. If you are not able to get to this step and click print, then maybe just take a screenshot of this or write your own answers and turn that in, just as some evidence that you have thought about these concepts. Thanks so much.